everyone. Just confirm audio video is clear. Please confirm audio video is clear. Just confirm me once whether audio video is clear or not. Audio video is clear, just check. Audio video is clear. Just check once and let me know. Good afternoon, Gagan. Audio video is clear. Just check audio video is clear. Very good afternoon. Good afternoon, Mathan. Audio clear. Okay, thank you. Thank you so much. So, a very good afternoon, everyone. Myself, Prateek Mishra, and I welcome you all to the YouTube platform of IMS GATE Academy. We are conducting this foundation series to make your basics strong so that you can get those highly conceptual questions in one go. Thank you. Voice is slow. Okay. Let me just adjust this a bit. Okay, now is it fine? So, in the previous session, we have discussed about the water demand, what are the different types of water demand. Then we have also classified the water demand as domestic demand, industrial demand, institutional demand, water for public use, and then we have the fire demand and thefts and losses. Then we have seen some of the basics, okay, one second, what about this one? Okay, then we have seen, very good afternoon, Vijay, very good afternoon. Now is it fine, Gagan? Is this fine? Okay. Then we have seen the basics of and some of the empirical formulas of calculating the fire demand. I hope you have read those topics again. After that, we have discussed about the different factors affecting the water demand. My dear students, you can expect a multiple select question from all those 8 factors that we have discussed regarding factors affecting the fire demand. Chalo. In the same series, continuing with the foundation, the next step is the quality analysis of water. Most of the questions that are framed in environmental engineering are framed from this topic. That is the quality analysis of water. Yesterday I have told you that there are the 2 major areas from where the question can be framed from raw water engineering. One of the area is quality of raw water. So today we will going to discuss about the physical water quality parameter, but before that I would like to make few announcements. If you want to have the schedule of the YouTube sessions and also the lecture PDF, you can join our Telegram group. The link is given in the description box. If you want to enjoy the daily quizzes and want to get job notification updates, again we update it regularly in our Telegram group. The link is given in the description box, so you can join that. Next, we at IMS GATE Academy, we provide you with 800 hours of live teaching with interaction, with doubt solving. We offer you 4 different types of courses. We offer you with online program, offline program, hybrid program, and the self-learning program. We provide you with theory and exercise book containing 4,000 plus practice questions well versed in level 1, level 2 and level 3. We provide you with a GATE question bank containing 34 years of GATE question, in which we have provided the detailed solution, alternate solution, video solution along with key points and chapter overview. We provide you with 12 personalized one-to-one mentoring sessions that actually help you to orient and plan your studies well. And we provide you with India's largest test series containing 130 plus tests. It's starting from the chapter test, subject test, multiple subject test, advanced subject test, and then the full length mock test. So these are some of the announcements. By these words, I would like to start my thing. So water supply engineering has this distribution starting for water demand, population forecasting, sources of water. Then we came to quality of water. The water quality is analyzed using water quality parameter. If you need to analyze the quality of water, it is analyzed using water quality parameter. There are basically three different types of water quality parameter: physical water quality parameter, chemical water quality parameter, and biological water quality parameter. Today we will going to discuss everything about physical water quality parameter. Okay, so one by one. What is a physical water quality parameter? Those water quality parameter which can be physically sensed or felt by any of our organs are classified as physical water quality parameters. In simple words, those water quality parameter which either can be see or we can feel or we can smell, those water quality parameters are classified as physical water quality parameters. So physical water quality parameters are basically of 5 types. First one is the suspended solids, second one is turbidity, third one is color, fourth one is taste and odor, and fifth one is temperature. You can see this. Suspended solids can be seen through the naked eye, hence classified as physical water quality parameter. Turbidity again can be seen through the naked eye, hence classified as physical water quality parameter. Color again can be seen, hence classified as physical water quality parameter. And then you have taste and odor which can be felt or smelt, hence can be classified as physical water quality parameter. And last one is the temperature, which again can be felt, therefore classified as physical water quality parameter. So those water quality parameter which can be felt or sensed by any of our senses are classified as physical water quality parameter. So I'll start one by one. I'll tell you, in these 5 physical water quality parameter, suspended solids and turbidity are actually important from your exam point of view, because if any conceptual question has to be framed, it can be framed from suspended solids or turbidity. Then there can be easy question which can be framed from these 3 areas that we also going to see. But our primary focus in today's session will be on these 2 physical water quality parameter. So I'll start with the first physical water quality parameter, suspended solids. But you can see here, I have written total solids, right? Now understand this. If this is your water sample, whatever I am saying, just you imagine this very properly, right? Because here your imagination part will play the key role. This is your water sample, and this water sample contains solids. This water sample contains solids. Some solids are seen through the naked eyes. So the solids that we can see through the naked eye is classified as suspended solids. You can see this. We have taken a water sample, and in that water sample few solids are there, and these solids are clearly visible in water. Therefore, these solids are termed as suspended solids. Then there will be other solids which are not visible through our naked eye. Those solids which are not visible through naked eye is termed as dissolved solids or TDS. Okay, so in the water sample there are 2 types of solid. The first type of solid which is visible through the naked eye is termed as suspended solids, and the solids which are not visible through the naked eye is termed as dissolved solids. Now you will say, sir, why you are telling this means at the same time? My dear, the analysis of total solids, suspended solids and dissolved solids is linked, right? But you have to take care that only suspended solid is a physical water quality parameter. Dissolved solid is the chemical water quality parameter. So I'll write here, total solids which are present in the water sample, total solids which are present in the water sample consist of suspended solids, and dissolved solids, Total solids which are present in the water sample consist of suspended solids and dissolved solids. Out of this, suspended solid is physically seen, hence it is classified as physical water quality parameter. It can be seen through the naked eye. It can be seen through the naked eye. Hence, it is classified as physical water quality parameter. quality parameter. I am coming to a very, very important conclusion, right? So stay here only. I am coming to a very, very important conclusion that can be one of the basic question in your interview. Suspended solids can be seen through the naked eye, hence it is classified as physical water quality parameter, whereas dissolved solids, it is not visible through the naked eye, it is not visible through the naked eye, hence it is classified as chemical water quality parameter. It is classified as chemical water quality parameter. It is classified as chemical water quality parameter. Now I am coming to my question, and the question is, can this suspended solid affect the chemical property of water? Can this suspended solid affect the chemical quality of water? This is my question, and this is one of the most basic question of any interview. What they will going to ask? They will going to ask whether this suspended solid can affect the chemical quality or not. My dear, suspended solid is a physical water quality parameter. It does not affect the chemical quality. Suspended solid does not affect the chemical quality of water. The chemical quality of water will be affected by chemical water quality parameter, in which dissolved solid is an example. Dissolved solid will going to affect the chemical quality of water. Suspended solid will not going to affect the chemical quality of water. So you can mention this as a note point, and you can write down. You mention this as a note point. Suspended solid solids does not affect the chemical quality of water. Does not affect the chemical quality of water. Does not affect the chemical quality of water. Chemical quality of water. Suspended solid does not affect the chemical quality of water, because suspended solid is a physical water quality parameter. Okay. So these are some of the basic. Now, sir, what about this total solid? Which kind of parameter is this? First of all, total solid is not one kind of parameter, right? Total solid consists of suspended solids and dissolved solids. So what you can say is, ki sir, total solid is analyzed as physical and chemical simultaneously, because total solid contains suspended solids and dissolved solids. Suspended solid is a physical water quality parameter, and dissolved solid is a chemical water quality parameter. Hence, we cannot keep total solids under one head. Okay, so don't have that confusion. Simple. Suspended solid, physical water quality parameter. Dissolved solids, chemical water quality parameter. Now coming to how to determine these type of solids. Usually in the examination, the question will be, what is the concentration of total solid? What is the concentration of suspended solid? What is the concentration of dissolved solid? So coming to that. So next topic of discussion is determination of solids. Determination of solids. Determination of solids. Determination of solids, right? Any type of solid, and this is the most accurate method. This is not the approximate method. It is the most accurate lab method. Most accurate lab method. It is the most accurate lab method. It is the most accurate lab method, right? It takes a lot of time, means it almost takes 24 hours, but still it is one of the most accurate lab method. Now see this. What we do is, we take sample of water, means we from any source, we contain the sample, right? Means how to collect the sample. We take the sampler, we fill that sampler with the water, right? Now we have this water sample. Now what we do is, we take equal volume of this sample. We take equal volume of this sample. So this is my crucible. Okay. This is my crucible like this. In this crucible, I have filled V ml of sample. In this crucible, I have filled V ml of sample like this. In this crucible, I have filled V ml of sample like this. in both the crucible I have filled V ml of water sample. In both the crucible I have filled V ml of water sample, right? Both the crucible contains V ml of water sample. Same water sample, not different. That's why these are termed as identical samples. Both the samples are from the same source and these two are termed as identical samples, right? So what we did, we have filled the identical, or we have collected or prepared the identical sample. Now this crucible contains V ml of water sample, okay? In this water sample, there will be both total solids and dissolved solids. There will be both total solids and dissolved solids like this. You can see this total solids I have drawn with yellow, and dissolved solids you cannot see, so I haven't drawn. Still, these are your dissolved solids. So this water sample contains both total solid and dissolved solid. Now what you do is, you take this crucible and you place it in an oven. Here you can see this is an oven. It is just like a refrigerator which maintains the higher temperature. In the refrigerator, you see that the temperature is maintained at the colder side or the lower side. But in an oven, the same process is there. The only thing is the temperature is maintained on the higher side, like around 100 degrees Celsius. So this is how the temperature is maintained. So what you did, you have filled V ml of the water sample in a crucible and you placed it in an oven, right? And you kept this water sample in an oven for 24 hours, at 104 degrees Celsius. You place this crucible in an oven for 24 hours at 104 degrees Celsius. At such a high temperature, what will happen is, this water will going to evaporate, and now this crucible will only contain the solids. All the water will going to evaporate and the crucible will only going to contain the solid. This is the crucible we have. Now this crucible will only going to contain the solid. So these are my solids, both dissolved solids and suspended solids. So these are my solids, both dissolved solids and suspended solids. So like this, only total solids will be there, right? Only total solids will be there. Like this, only total solids will be there. Only total solids will be there. All the water will going to evaporate at such a high temperature for such a duration. Now what you do is, you simply measure the weight of the solids. You simply measure the weight of the solids. 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 Measure the weight of the solids that are left in this crucible. Okay. Say this weight is W1. Say this weight is W1. So these solids are your total solids. It is the sum of suspended solids and dissolved solids both. So now I got the concentration of total solid, that is equal to W1 divided by the volume of the water sample. So the concentration of total solid is, total solids concentration will be, total solids concentration will be weight of the solids, that is W1 divided by the volume of the solid. So this weight is in grams and this volume is in ml. So accordingly you can change the units. Usually we represent this in gram per liter, so you need to multiply by 1000, right? So this is how you calculate the concentration of total solids. Okay, now see this. Most of you have this confusion, sir. How we calculate this W1? Arey bhai sahab, before starting the experiment, you measure the empty weight of the crucible. Then after 24 hours, you take out this crucible from the oven and you again take the weight of it. Just take the difference of this weight minus the empty weight of the crucible. That will going to give you the weight of the solids, and that is W1. Please remember, W1 is the weight of solids, not the weight of solid plus crucible. Okay. It is only the weight of solids. And this W1 is equals to this total weight minus empty weight of the crucible. Simple. This is just a very simple logic, right? So this is how we do. This sample which we have taken out from the oven, this is known as oven dried sample. This is known as oven dried sample. This is known as oven dried sample, right? I am writing down all the important terms that can be seen in the question. Usually if you get a question from these total solid, they're literally going to explain the entire experiment. That's why a lengthy question is framed from this topic, and most of the time this is such an easy question to attempt, but just by seeing the length of the question, student just leave it. So try to understand the process. What you did, you take the crucible, you filled V volume of the water sample, and you place this crucible in an oven for 24 hours at 104 degrees Celsius. At such a high temperature and for such a duration, all the water will going to evaporate, and now you are only left with suspended solids and dissolved solid, that is total solids in the crucible. And you simply take the weight of the solids, and this weight of the solid is the weight of total solids. So you know the volume of the sample, that is VmL. You know the weight of total solid W1. You can calculate the concentration of total solid, that is equal to W1 by V. This is in gram, this is in ml, right? Accordingly, you can change the units. Now next, what you need to do is, but we want to calculate the concentration of suspended solids. We want to calculate the concentration of dissolved solids. So for that, what we do, this second identical sample that we have, this second identical sample will also contain suspended solids and dissolved solids like this. This second identical sample will also contain suspended solids and dissolved solids like this. Now see what we do. This second identical sample will contain both suspended solids and dissolved solids like this. Now see what we do. First, we pass this water from the filter paper. We pass this water from the filter paper. We pass this water from the filter paper. We pass this water from the filter paper, right? Now, sometimes in an interview, they ask which type of filter paper is there. So it is Wattman 42 number size filter paper. This is Wattman 42 number size filter paper. This is Wattman 42 number size filter paper, right? The pore size is 0.2 micron. Okay, so you simply take this crucible, you simply take this water and pass through the filter paper, and while water is passing through the filter paper, all the suspended solids will be retained over this filter paper like this. All the suspended solids will be retained over this filter paper like this, and through this filter paper only dissolved solid passes. Through this filter paper only dissolved solid will going to pass like this. So this is this is your water sample. Now this water sample that you have collected like this, right? This water sample that you have collected here will contain only dissolved solids. This water sample will contain only dissolved solids because all the suspended solids are retained over the filter paper. Now this water sample will only contain dissolved solids. This will only contain dissolved solids because all the suspended solids are retained. So this is my retained suspended solids. I should write it with another color. So this is retained. This is retained suspended solids. This is retained suspended solids over the filter paper, right? And this water sample will contain only dissolved solid, contains only dissolved solids. Contains only dissolved solids, right? Now what you do is, this crucible you place in an oven again at 104 degrees Celsius for 24 hours. This crucible you place in an oven again at 104 degrees Celsius for 24 hours. For such a duration and for such a high temperature, what will happen is, again all the water will evaporate from the crucible, and now this crucible will contain only dissolved solids. When you place this crucible in an oven for 24 hours at 104 degrees Celsius, in an oven, here you have placed this an oven, right? And this is also oven. You have placed this in an oven, right? So all the water will going to evaporate, and now you are only left with the dissolved solids. So this crucible will now only contain the dissolved solids. This crucible will only contain the dissolved solid like this. This crucible will only contain the dissolved solid like this. Now what you will going to do is, you will going to measure the weight of the dissolved solids. So you just measure the weight of the dissolved solids. Measure the weight of dissolved solids. Measure the weight of dissolved solids, and this weight be W2. This weight say W2, right? So you have measured the weight of the dissolved solids. Now you can calculate the concentration of dissolved solid. So concentration of dissolved solid is W2, weight of dissolved solids, divided by the volume of the sample, that is VML. So you have also measured the concentration of dissolved solids. So I will write down dissolved solids concentration is weight of dissolved solid, that is W2 gram, divided by volume of the sample, that is VML. So that will be the concentration of the dissolved solids, right? So now you know the concentration of total solids, you know the concentration of dissolved solids. Now the only thing left is the concentration of suspended solids. So for measuring that, what we do is, here you can see this filter paper, right? This is the filter paper over which all the suspended solids are retained, right? Here you can see this filter paper over which all the suspended solids are retained. We never keep this filter paper in the oven, right? We don't do anything of this filter paper. Don't keep this in your mind that we will going to keep this filter paper in an oven and then measure the change in weight. Never do that. Reason is, when you keep this filter paper in an oven, there is a possibility that the weight of filter paper may change. And due to the change in weight of filter paper, the amount of suspended solids that you will going to calculate will contain some error. That's why we never keep this filter paper containing the suspended solids in an oven. On the other hand, what we do is, we know the concentration of total solids, we know the concentration of dissolved solids. By subtracting the concentration of dissolved solids from the total solids, I can get the concentration of suspended solids. So suspended solids concentration is total solids minus dissolved solids. Total solids minus dissolved solids. We use one basic equation, that is total solid is equals to sum of suspended solid plus dissolved solid, and we calculate the suspended solid, right? We never keep the filter paper in an oven. Reason is, there can be a possibility that change in weight of the filter paper may happen, and that eventually produce error in the calculation of suspended solids. So you can write down again this as a note point. Note: filter paper containing suspended solids, filter paper containing suspended solids, filter paper containing suspended solids is not kept in an oven, because there is a possibility of weight change, because there is a possibility of weight change of the filter paper. Because there is a possibility of weight change of the filter paper, right? So this is like one of the very, very important fact that should be kept in mind. We never keep the filter paper in an oven. we will always going to keep the crucible which is containing total solids and the crucible which is containing dissolved solids. And by subtracting the concentration of dissolved solids from the total solids, we will calculate the concentration of suspended solids. This is how we do, okay. So this is how we can calculate both suspended solids and dissolved solids along with the total solids. Again, I will repeat myself. Suspended solid is a physical water quality parameter. Dissolved solid is a chemical water quality parameter. But since the method of calculation is related, that is why we have read both of them here itself. So this is how we do. Now, my dear students, again, solids are of two types, and this is the very basic classification. So you have two types of solids. Solids are of two types. Solids are of two types, right? What are those two types of solid? A solid can be either an inorganic solid. A solid can be either inorganic solid, or it can be either an organic solid. Or it can be either an organic solid. Okay. So a solid can be either inorganic solid or it can be either an organic solid. Inorganic solids are also known as fixed solids. Inorganic solids are also known as fixed solids. Similarly, organic solids are known as volatile solids. Organic solids are known as volatile solids. So there should be no scope of confusion, right? Any type of solid can be of two types: inorganic solid or organic solid. Inorganic solid is also known as fixed solids. Organic solids is also known as volatile solids. Now we have seen three different types of solids: total solid, suspended solid and dissolved solid. So all these three types of solid can be classified as inorganic or organic, okay. So I will write down, if I talk about total solids. Total solids are of two types. Inorganic total solids, I am using the notation, right? Inorganic total solids or organic total solids. Or organic total solid. For inorganic, I will use IN, and for organic, I will use O, right? For inorganic I use IO, not IN. I will use IO, inorganic total solids and organic total solids. So I think this should be clear to you. So total solids are of two types: inorganic total solids and organic total solids. Similarly, suspended solids are of two types. Suspended solids are of two types. So you have inorganic suspended solids. So you have inorganic suspended solids and you have organic suspended solids. Organic suspended solids. So you have either inorganic suspended solids and organic suspended solids. Similarly, for dissolved solids, again they are of two types. Dissolved solids are of two types. Dissolved solids are of two types. So you have inorganic dissolved solids. This is inorganic dissolved solids, and then you have organic dissolved solids. Inorganic dissolved solids and organic dissolved solids. This is inorganic dissolved solids and organic dissolved solids, right? So this is the proper classification of all the different types of solid. Now see how deep question can be framed from this area. First, you have classified solid as three types: total solids, which includes suspended solids and dissolved solids. Now all these three types of solids can be further classified as inorganic organic, inorganic organic and inorganic organic, okay. Now if the question comes in the examination, they may ask you any type of solid. Now reading all this is a bit confusing sometimes, but if you follow my method, it is one of the easiest way to understand and it is the easiest way to remember things. And what my method says is, in the previous experiment, we got two oven-dried sample. First one is this. This is the oven-dried sample for total solids. And this is the oven-dried sample for the dissolved solids. Okay. What you have to remember, in the previous example, we got two oven-dried sample. This is the overnight sample for total solids, and this is the overnight sample for dissolved solids. Simple. You have to just pick this overnight sample and you place this in the muffle furnace. This is your muffle furnace. Okay. You took the overnight sample of total solids. So, overnight sample of total solids. Let me draw this. This is the overnight sample of total solids. This is the overnight sample of total solids containing both suspended and dissolved solids. This is the overnight sample of total solids. This is the oven-dried sample of total solids. This is the oven-dried sample of total solids. Okay, from the previous experiment only we have taken this oven-dried sample of total solids and we place this in the muffle furnace. This is the muffle furnace. You can see it is an advanced version of your oven. In the muffle furnace, you can maintain higher temperatures like 500, 600, 7 degrees Celsius. So that kind of temperature is maintained. Okay. So usually you heard a lot of things starting from the refrigerator, then you have incubator, then you have oven, then you have muffle furnace. So the work principle of all these equipments are same. They maintain the temperature at certain range. Okay. Refrigerator maintain the temperature on the colder side. Furnace, oven maintains the temperature on the higher side. Incubator maintains the temperature in the normal range, right? So you have this muffle furnace. So you take this oven-dried sample of total solid and you keep this in muffle furnace. You keep this in muffle furnace. I have also attached the diagram of muffle furnace. So you keep this in muffle furnace at 550 to 600 degrees Celsius, at 550 to 600 degrees Celsius for the duration of 2 hours. Very simple. You have taken the oven-dried sample of total solids and you keep this in the muffle furnace at 550 to 600 degrees Celsius for the duration of 2 hours. At such a high temperature and for such a duration, inside the muffle furnace what will happen is, whatever organic fraction of total solid is present, it will going to vaporize. And now you are only left with the fixed solids or the inorganic solids. So after 2 hours, when you take out this oven-dried sample from the muffle furnace, you will only going to get the inorganic solids. All the organic solids will going to vaporize. So when you keep this oven-dried sample in the muffle furnace for this duration of 2 hours at 550 to 600 degrees Celsius, so what will happen is all the organic solids will going to vaporize. All the organic fraction of total solids will going to vaporize. Organic fraction of total solids will vaporize. Organic fraction of total solids will vaporize, and now you are only left with the fixed total solids. This is the fixed total solids or inorganic total solids. You are only left with the fixed total solids or inorganic total solids, right? So you simply take the weight of this fixed total solids. So you simply take the weight of fixed total solid is measured. Fixed total solids is measured. And this weight is W1 dash. This weight is W1 dash. And what is W1 dash? W1 dash is the weight of fixed total solids. Okay. Now from here I can calculate the concentration of fixed total solids or inorganic total solids. See this, how we are doing it. So concentration of fixed or inorganic total solids, fixed or inorganic total solids, inorganic total solids is equal to W1 dash in gram divided by the volume of the sample, again which is VML. This is the concentration of fixed or inorganic total solids. Okay. Now from here I can calculate the concentration of organic total solids. How we will going to do that? So I know that total solids is the sum of inorganic total solids plus organic total solids. Total solid is the sum of inorganic total solid plus organic total solid. You can see here, you know the weight and concentration of inorganic total solids, you have just now calculated. And you also know the concentration of total solids. So by subtracting the concentration of inorganic total solid with the total solid, you can calculate the concentration of organic total solid. So just in one step, you have calculated the concentration of inorganic total solid, and using that you have calculated the concentration of organic total solid. So this equation is clear. Please tell me, is this equation is clear to you? This is again a very logical thing, right? There is no rocket science in this. A very simple experiment performed to calculate the different quantities. But the only thing is, when the same thing comes in the examination, it will come in the form of huge question. And after seeing the question, student feels like what to do. So my simple answer to you is, you first observe what is given in the question. Whether they are talking about the oven, that is your step number 1, whether they are talking about this process of the oven, or whether they are talking about the muffle furnace. Whether they are talking about the muffle furnace. So my simple answer is, if they are talking about the oven, then they will be talking about either total solids or dissolved solids. Simple. But if they are talking about the muffle furnace, then most probably they will be asking you what is the amount of organic total solid, what is the amount of inorganic total solids. So like that, they will going to ask about the organic and inorganic fraction. One of the times a question came in the examination, what is the organic fraction of total solids? So from here you have calculated the concentration of inorganic total solids and organic total solids. So from here itself you can calculate the organic fraction. So I'll write here, organic fraction of total solids, organic fraction of total solids is equal to organic total solids divided by total solids multiplied by 100. Simple. This is the organic fraction of total solid. From here only you can calculate the inorganic fraction of total solid. So inorganic fraction of total solid, inorganic fraction of total solid, this is equal to inorganic total solid divided by total solid into 100. Again, we have seen a lot of questions from these two formulas as well. Okay. And these two formulas are only applicable once you have calculated the concentration of organic and inorganic total solids. Okay. So these are like simple logical questions that can be framed. But in order to reach this step, you need to understand all the previous steps that are explained in the question. Okay. So from here we have calculated the organic total solids and inorganic total solids. Now coming to the other two, that is how to calculate the concentration of dissolved organic solids and dissolved inorganic solids, and organic suspended solids and inorganic suspended solids. Now see this. Okay. So the story of this filter paper is over here itself. We are not using this filter paper in an oven, so no point in using it in muffle furnace, because at that high temperature the filter paper will going to burn and nothing will be left, right? So the story of this filter paper is over. You leave it here itself. Now the next thing that is left with us is this oven dried sample of the dissolved solids. This is the oven dried sample of the dissolved solid that only contains the dissolved solids. So you take this oven dried sample of the dissolved solid and again you place it in the muffle furnace. You take the oven-dried sample of the dissolved solids. So you take oven-dried sample of the dissolved solids like this. This is the oven-dried sample of dissolved solids. This is the oven-dried sample of dissolved solids. Okay, this is oven-dried sample of dissolved solids like this. This is oven-dried sample of dissolved solids. Oven-dried sample of dissolved solids. This is the oven-dried sample of dissolved solids, right? In this oven-dried sample of dissolved solid, again you place this in the muffle furnace at 550 to 600 degrees Celsius for the duration of 2 hours. Again you place this in muffle furnace. Again you place this in muffle furnace at 550 to 600 degrees Celsius for the duration of 2 hours. Here you can see this is the muffle furnace, right? Here I have literally attached one image of the muffle furnace. Inside this muffle furnace you place this sample like this, right? You can even see some of the crucible that are placed in the muffle furnace. So you take this oven-dried sample of dissolved solid and you place it in the muffle furnace. Again at this high temperature of 550 to 600 degrees Celsius, all the organic fraction of dissolved solids will going to vaporize, and in the crucible you are left with the inorganic dissolved solids. All the organic fraction will going to vaporize like this. So after 2 hours, all the organic fraction of dissolved solids will going to vaporize. So this is organic fraction of dissolved solid vaporizes. Organic fraction of dissolved solids vaporizes, and in the crucible you are only left with the inorganic dissolved solid. This is only inorganic dissolved solid. These are only inorganic dissolved solid. So you simply take the weight of inorganic dissolved solids. So measure the weight of inorganic dissolved solids. Measure the weight of inorganic dissolved solids. Inorganic dissolved solids, right? And say this weight is W2 dash in grams. You measure the weight of inorganic dissolved solids. You have to simply take the weight of inorganic dissolved solids. Now from this weight, you can actually calculate the concentration of inorganic dissolved solids. So let's do this. I'll write this in the next slide. So concentration of inorganic or fixed dissolved solids this is equal to the weight of fixed dissolved solids, that is W2 dash in grams, divided by the volume of the sample. So volume of water sample is VML. So this is how you can express the concentration in gram per ml or gram per liter. Accordingly you can do this. So you have calculated the concentration of inorganic dissolved solids, and you also know the concentration of dissolved solids. So from that you can calculate the concentration of organic dissolved solids. So dissolved solids is equal to the sum of inorganic. I am writing all the terms, so if any term comes in the examination, you are not confused. So dissolved solids is the sum of inorganic or fixed dissolved solids plus organic or volatile dissolved solids. Organic or volatile dissolved solids. Okay. So you know the concentration of dissolved solids, you know the concentration of inorganic dissolved solids, you can calculate the concentration of organic dissolved solids. Now again the same type of question can be framed. What is the fraction of organic dissolved solid and what is the fraction of inorganic dissolved solids? So again I will write like this: organic fraction of dissolved solids, organic or volatile fraction of dissolved solids is equal to organic dissolved solids divided by dissolved solid concentration multiplied by 100. Simple. Organic dissolved solids divided by dissolved solid concentration multiplied by 100. This will going to give you the organic or volatile fraction of the dissolved solids. Now next, inorganic or fixed fraction of dissolved solids is equal to inorganic dissolved solids divided by dissolved solids into 100. Inorganic dissolved solids divided by dissolved solids into 100, right? So this is how, again, in this entire slide, right, there are 3 questions which you can expect as a 1 mark or a 2 mark question. Especially if a question comes from this organic or inorganic fraction, it will definitely be a 2 mark question. You can expect one easy question for calculating the inorganic concentration of the dissolved solids. So you can expect almost 3 to 4 questions from this single slide. Similarly, you can expect again 3 to 4 questions from this slide. Okay. Now, after this, what all things we know? We know organic total solids, we know inorganic total solids, and we also know the concentration of total solids. So I will write down, better it will be easy for you. So what all things I know? I know concentration of total solids, I know the concentration of inorganic total solids, and I also know the concentration of organic total solids, right? Then I know the concentration of dissolved solids, I know the concentration of inorganic dissolved solids, and I know the concentration of organic dissolved solids. I know the concentration of organic dissolved solids. I also know the concentration of suspended solids. Now the only thing that is left is the concentration of inorganic suspended solids and the concentration of organic suspended solids. These 2 things I need to determine. Okay. Now you can see here the manner in which I have written, from that manner only you can have an idea what will be my next step. Okay. So you see this. When you just check out this column, can I write down inorganic total solids, inorganic total solids is equal to inorganic dissolved solids plus inorganic suspended solids is equal to inorganic suspended solids. So you know the concentration of inorganic total solids, you know the concentration of inorganic dissolved solids, you can very easily calculate the concentration of inorganic suspended solids. So first problem is rectified. Now for calculating the concentration of organic suspended solids, either you can use this column or even you can use this row. It is totally your choice. Either you go with the column equation or either you go with this row equation, right? So both the equation I will write. First one is organic total solids is equal to organic dissolved solids plus organic suspended solids. So organic total solid is equal to the sum of organic dissolved solids plus organic suspended solids. So this is one equation that I have framed from this column. Now next equation that I can frame from this row is suspended solid is the sum of suspended solids. Suspended solids is the sum of organic suspended solids, is the sum of organic suspended solids plus inorganic suspended solids, plus inorganic suspended solids, is the sum of organic suspended solids plus inorganic suspended solids, plus inorganic suspended solids, right? So you know the concentration of suspended solids, you know the concentration of inorganic suspended solids, you can calculate the concentration of organic suspended solids, right? Please remember this matrix, okay? This can be summed, this can be summed, and this can be summed. Similarly, this can be summed, this can be added, this can be added, okay? So what you can do is, total solid is the sum of inorganic total solid plus organic total solid. Similarly, dissolved solid is the sum of inorganic dissolved solid plus organic dissolved solid. Total solid is the sum of suspended solid is the sum of inorganic suspended solid plus organic suspended solid. When you go this column wise, so total solid is the sum of dissolved solid plus suspended solids. Inorganic total solid is the sum of inorganic dissolved solid plus inorganic suspended solid. Inorganic total solids is the sum of organic dissolved solids plus organic suspended solids. So like that, you can frame different equations as per your convenience. If I have to write down everything, so you can take down these equations. So total solid is the sum of dissolved solids plus suspended solids. Then total solid is also the sum of inorganic total solid plus organic total solid. Then you have this dissolved solid is the sum of inorganic dissolved solid plus organic dissolved solids. Then you have suspended solid is the sum of inorganic suspended solid plus organic suspended solid. Then again you can write down inorganic total solid is the sum of inorganic dissolved solids plus inorganic suspended solids. Then next, organic total solid is the sum of organic dissolved solids plus organic suspended solids, okay? So these are some of the basic equations that you can use for calculating the different quantities that are asked for the suspended solids, right? Okay, this almost took our session, right? I was expecting to complete this thing and one more parameter, turbidity, okay? But no problem. If you are there in our course, in our classroom, we will going to see everything in detail along with the numericals, okay? So this is one of the very, very important area from where we are seeing some regular questions. So you can take down all these things. If you want this lecture PDF, it will be available in the Telegram group, right? So quickly I just make few more announcements and then I would like to close this. Okay. So you can join our Telegram group. Again, the link is given in the description box for this lecture PDF and for the YouTube lecture sessions and also for the schedule of YouTube. You can join for our Telegram group. We provide you with important updates related to the seminar and webinar that we regularly conduct, and we also provide you with the information regarding any PSU or government job notification if it comes. To enjoy the daily quizzes, again we post regularly on our Telegram group, so link is given in the description box. We at IMS GATE Academy, my dear students, we offer you with 800 hours of live teaching with interaction, with doubt solving. We provide you with theory and exercise book containing 4,000 practice questions which are well versed in level 1, level 2 and level 3, so that even you can analyze what is your preparation level. We provide you with 34 years of GATE question bank, and it is one of the most premium product, one of the most required product for GATE preparation. If you have this GATE product, right, you might means you don't need any other practice material. It is sufficient in itself. 34 years of GATE questions. In GATE examination, questions may not be repeated, but the concepts are repeated frequently. So you can practice all those concepts using this GATE question bank. In our GATE question bank, we provide you with the detailed solution, alternate solution, video solution, along with the key points and the chapter overview. IMS GATE Academy is the only academy to provide personalized mentoring. We provide you 12 personalized one-to-one mentoring session, which keeps you oriented and motivated towards the entire journey of GATE preparation. And we provide you with India's largest test series containing 130 plus tests, including chapter tests, subject tests, multiple subject tests, advanced subject tests, and then the full length mock test with the video solution. This is the proper feedback system that any student requires while preparing for GATE exam. If you want to speak to our counselor, you can just take down these two numbers. You can speak with Chaitra ma'am and Rahman sir, and you can discuss about any other queries that you have. We are running offline center in Bangalore, and we are available pan-India for the online services. So you can join any of our program. We provide you with 4 different types of program: online program, offline program, hybrid program, and the self-learning program. So this is all for today. I hope you have got enough information and you have enjoyed the lecture. Thank you so much for listening patiently. I'll see you tomorrow, same time, same place. For today, PM is signing off. Have a great day ahead. Thank you so much.